Hello viewers, welcome to our today lecture. In our previous lecture, we have discussed about the VAR model, and that is unrestricted VAR model. In our today lecture, we are going to discuss about the restricted VAR model, and that is also called vector error correction model. But before applying vector error correction model or VECM, there are two conditions that have to be filled. The first condition is that your all variables are stationary at first difference, and the second condition is that your all variables are co-integrated. So first of all, you have to check the stationarity of the data. If you have any confusion in checking the stationarity of the data, you can see the earlier lectures in which I have explained in detail that how can you check the stationarity of the data. So after checking the stationarity of the data, then you can move forward to the second condition, and that is your R variables must be co-integrated. So I am assuming that my all variables are stationary at first difference. So first of all, I have to select the data from the Excel file. As my data start date is 1976 and it ends at 2020, and it is yearly data. So after that, I will go to file. Then I will select work file, and I have to mention the start and end date of the data. As you can see that my data start date is 1976 and it ends at 2020. So, and as I mentioned that my data is annual, so from this option I have to select that my data is annual, and my data set has start and end date, so I am going with this option, dated or regular frequency, and then you have to click on OK, and after that go to quick, then empty group, and paste your selected data here. So I am assuming that my all these three variables are stationary at first difference. Now I have to apply Johansson co-integration test in order to check the co-integration between these variables. So I will go to quick, then I will go to group statistic, and here you can see that there is Johansson co-integration test. So now it is asking about the list of variables or list of the series. So I have to write my all variables here, GDP, saving and import, and then I will click on OK. You can change these options by your own choice. If there is no intercept in your data, if there is intercept or trend, or you can go by the default option. I am assuming that there is intercept or no trend in my data, and here you can change the lag interval depending on the size of your data set. If you have large observation, then you can increase the number of lags in your data set. So this first one is, and this one is indicating the number of lag for your variables, dependent and independent variable. So after that you have to click on OK. So these results of Johansson co-integration test, none mean that there is no co-integration equation in your model. At most one mean that there is one co-integration model. At most two mean that there are true integration model in your equations. You have to see the probability value of the every equation, and if your probability value is less than 0.05, you have to reject the null hypothesis. And null hypothesis is that there is no long run co-integration. Okay, I will write the H naught is the null hypothesis. There is no long run co-integration, and the alternative hypothesis is that there is long run co-integration. So as my p value is less than 0.05, so I have to reject the null hypothesis and I have to accept the alternative hypothesis, which means that there is long run co-integration. Similarly, you can see that it also mentioned here that trace test indicate 3 co-integration equations. There is another method for checking the long run co-integration, that is max eigenvalues. This test also indicate you that max eigenvalues test indicate no co-integration at the 0.05. So this test indicate that there are 3 co-integration equations, and this test also shows that there are 3 co-integration equations. As the probability value is less than 0.05, so we have to reject the null hypothesis, meaning that there exists a long run co-integration between the variables. So after that you have to go to quick, as our 2 conditions are fulfilled, that our variables are stationary at first difference and they are co-integrated. Now we can apply the VECM model. So go to quick, then estimate VAR, and here you have to select the VEC, vector error correction, or VECM vector error correction model. So here you have to write the all variables like saving, GDP and import. As you have 3 variables, so there must be 3 equations, and as you have see that it is asking about the lag interval, you can change the lag by your own choice. I am going with the standard setting. So here you can see that it gives you the result for VECM model, error correction. As I mentioned earlier that your all variables must be stationary at first difference, and if your variables are not stationary at first difference, VECM automatically convert your variables to first difference. And you can see that here D is representing for first difference, and as you can see that there are 3 variables in your model, so there are 3 equations, and as you can see that you have included 2 lags. So this is showing lag 1, this is showing lag 2, and this is lag 1 for the second variable, lag 2 for the second variable, and this is the lag 1 for the first variable, and this is the lag 2 for the first variable, and C is the constant. And these variable, these coefficient or these values in these brackets are standard error, and these are the t-statistic values, as shown here that these brackets are showing standard error and these are showing t-statistic. You can calculate the t-statistic by dividing coefficient with the standard error. So as we have 3 equations and we have 7 coefficients in each equation. So there are 21 equations overall, 21 coefficients overall. But the problem is that we have to see the p-values, but in this case we have no p-values, so it is difficult for us to explain that whether these results are significant or not. So we have to see the p-values. So for obtaining the p-values, we go to the proc, then we go to the make system, and we have to select the option ordered by variable. As you can see that this is our first equation, this is our second equation, and this is our third equation. And these are the co-integration equation 1, 2, 3. As the result shows, there are 2 co-integration equation. And after that we have to go to estimate, and we have to click on OK. So it will give the p-values. So as you can see that this is our first equation, and it is for saving with first difference, and its coefficients start from C1 to C8, and C8 is showing the constant for this specific equation. If the p-value is greater than 0.05, so it means that that particular coefficient is not significant in this model. And as you can see that this C9, its p-value is less than 0.05, it indicates that this variable is, or this coefficient is significant in that particular model. Other than that, you can see that all variables are insignificant as their probability values are greater than 0.05. So you can see that this is your first equation, this is second equation, and this is third equation. So from C9 to C16 are the coefficient for the second equation, C17 to C24 are the coefficient for the third equation. You can also check the joint significance if you want to check that whether these two variables are like C1 and C2 are jointly affecting the your dependent variable. You can also check. So if we want to see that C2 and C3 are jointly affecting the dependent variable, we can also check that. We have to go to view, then we will go to coefficient diagnostic test, then we apply World coefficient test, and here we have to mention the coefficient in which we are interested to check their joint significance. So after we have to click OK, and this will give us the results. So the null hypothesis is that there is no joint significant, and H1 is there is jointly significance, and we have to see the probability value of the chi-square. If it is less than 0.05, we have to reject the null hypothesis. But our probability value is greater than 0.05, so we have to accept the null hypothesis, which means that C1 or C2 and C3 are not jointly affecting the dependent variable. Okay, H0 is there is no joint significance, H1 is there is joint significance, and if p-value is less than 0.05, reject the null hypothesis. By rejecting the null hypothesis, you are saying that there is joint significance, but in our case our probability value is greater than 0.05, so we have to accept the null hypothesis, which means that there is no jointly significance of C2 and C3 on the dependent variable. So this is all for the VECM model. If you have any question, you can